Okay, so let's go for data source level. This is go back to the data source. The left bottom corner, we have the data source option. You can see the list of tables which we have it and how we are going to be related the tables. Okay, first we can see that joins. Okay, remove it here. So I have a EMP table. Double click on it. You can go for physical EMP table. This is a physical table which we have. So first question, can we join multiple sources in the Tableau? I'm getting EMP table from the uh, Excel. I'm getting DPT table from the text file. Can we
Yes,
join these two?
yes.
Yes, we can join the two different sources of data and we can get a single output from both the files. Okay, we can join the two different sources of data as well. Okay, so how we can do that? Let me create a simple tables here. So new, I can create a text file where I have the DPT data. Okay, already DPT is there. Let's see EMP4, EMP1. Now the EMP data, yeah, EMP. Yeah, I have EMP data, EMP number, rename, salary, departments. Do you have the DPT data as well? So I can put this DPT data into the Excel file. Okay, let me go for create an Excel file. Okay, project. Let me do the data and what is the option we have? It export from text. Okay, we can directly import the text file into the Excel. Desktop, you can go for it. Yeah. Which one we are taking? EMP or DPT? DPT, right? EMP, any one of it. Okay, so delimiter which we have it, comma separator, right? That would be fine. Next, tab or comma. It is a comma separator. Semicolon, comma. Next, finish. Okay, I have the DPT number, DNAME, location. File, same as, and desktop. The name of country. Okay, keep it as country or put it as a DPT. Save it. Okay. Let's go for here. I have the EMP table. Uh, even try with Snowflake is the EMP table. I have it. Let me bring the DPT table from where we are taking from the text file. So how I can get the text file here? Go for add. Okay, text file. What is my text file name?
DPT.
DPT. Okay. Can you see this? So this is the EMP table which I am getting from Snowflake, and I have the DEPT table which I am getting from text table. So the relation it's showing the wrong. So you need to manually give that relation between these two tables. Okay. So what is from the EMP table? I want to take the DEPT number. From DEPT table, I want to take the DEPT. Can you see that? I have joined these two sources. One is from the Snowflake table, another one is from the text table. So I want to see the matching data here. Just update now. Click on the update now. What are the matching records are there? Those we can be displayed. Okay. We can get the matching data in the both the. So you can go for combine the two different sources of data and we can bring into single output. So what are the four types of joins we have it here? Inner join, left join, right join, and full outer join. Inner join, left join, right join, and full outer join. four types of joints we can do it in physical modeling. It's like a physical joints. These are the physical joints we can call it. Physical,
Same as
yeah,
just a question. So is
yeah,
this
Raj.
data bending or is it just adding two connections? I
This
mean,
is not data blending. I will tell you how to do the data blending. This is a pure joining. Okay,
okay, okay.
pure joining, but where is go for different data sources even. If you have the proper relation in the both the tables, you can join it. Okay, where the joins are not supported, there we can go for data blending concept. Until
Mhm,
joins supported, then you can use the joins.
mhm.
Okay.
Okay,
So
okay,
here
okay.
I have a proper relation. Yeah, DPT number in EMP table, DPT number DP table. I can join it and get the data into the out. Okay.
Okay, sir.
This is a physical join. This is we can call it as a physical join. Okay. Let me go for
Srinivas, what is the default join which Tableau accepts?
inner join. By default, it will take the inner join.
Okay.
Okay. And here you can see how many tables can we join. They will ask you question like this. How many tables can we join here? Max 32 tables we can join. Okay.
How much?
Max
30,
30,
30, 30 or
32,
32? 32,
32
32.
tables we can join. 31 joins should be there.
Okay.
Okay. The relationship will be 31. Total 32 tables we can join here. Okay. The max. Right. So let's go for this is a all two joins are there in that. This is a logical table of EMP. The logical table we can call it as a container for the physical joints. The logical table call it as a container for the physical joint. Double click on it, you can get the logical table. Okay. Sir, why EMP is showing as a container? Why don't you make it as a DEPT? Which is the first table you can drag it? That will show like here. Okay. The logical table, which table you can drag it into the first. This is called area. We can call it as a canvas. If you drag the DEPT first, that's a root table. We can say that. Okay. The root table. So that is called as a logical table. It can be shown. Double click on it. You can go for see that physical join. Just double clicking on it. And one more data model you want to make it, yes, you can drag the table here. Okay. And double click on it. Go for drag the EMP1 or EMP. One more model you can create it. Here, the relationship you need to define it between these two logical tables. Okay. So common field, whatever you want to be define it, you need to specify that. From EMP, DEPT, DEPT, I want to connect it. Then go for make it as DEPT. From EMP or DEPT, you want to go for EMP. Okay, we can make a relay. This is called a relationship. This is called a relationship. This is called a join. This is called a join. Okay, this is all called a physical joins, and this we can call it as a relationship. Okay, relationship means it's just making it related to the each table. Okay, there is no physical join. Okay, Tableau will take care of the getting the data. So what is the main difference here is when you go for related the data, these two tables are always individual, distinct. Okay, these two tables are distinct. When you go for physical join, so Tableau will combine these two tables data and it will create a one, it will
Single,
merge the two tables and will get the one, yeah, single record table.
s- merging will happen in
Yeah, data merging will be happens in the physical
in
join.
joints. In joints, merging will happen. Relation. I mean, they are different.
Yeah, data merge will be happens and it will get the single output. Data all will be merged and it will get the single output. Whereas relations, these both are individual. Okay, it cannot be merged. Once the data get better, which is the better you can go for use it until unless the relationship is the give a better performance to your report. The relationship will give the better performance to the reports. Okay, this is a logical layer we can call it. This is called a logical layer. So how we can define the star schema here? How we can define the star schema here? So simple. If you have multiple dimension tables, you just drag it and map with the root table. It's automatically mapped with the root table. That's why first you need to drag the fact table. then drag the dimension to related it, automatically they can join with the fact table, the root table, which we can have it. Okay, so I don't have the star schema model here. Maybe I will show you that. Whereas I have Excel data at least in different dimensions. In fact, maybe I have saved in Excel format. Let me check that. So that will give you that how the data model we can build a star schema model. Okay, so Azure somewhere I saved it. Let me pull that. Uh,
Just
I have it.
yes, Srinivas, I have a small query.
Yeah, Shrikant.
Yeah, we have a logical table as a EMP table. Just now you are taking the EMP table, and at the same time text table department which is in text table which we have created.
Okay.
Now I came to know that there is a difference in the department table data and already inbuilt logical table. Can we map the two department tables to the EMP table at a single stretch?
No, I didn't get your question.
Here you have created a DEPT table, and here at the left side, the top of the corner. Yeah,
Okay.
okay. Already in the Snowflake also we have DEPT table, I think.
Yeah.
So
So in the
later on,
snow to
I
build
came
that
to know that there is a difference between the difference in the data in the DEPT which have been loaded from the desktop and already which are having in the Snowflake. So can I bring this two DEPT table to EMP table? Can I give the connection like that?
yeah, you can give the relationship multiple tables here. Okay, the relationship just you need to define it. Okay, so double click on it here and go for select that. What is the relationship you want to make it as? So DPT number, and I can go for here. I have a DPT number. Okay, you can make the relationship. So this is kind of join. We can relationship. We can say that here. It's like a star schema kind of thing. Multiple dimension tables. I can drag it. Okay. So here you can see this is the fact table and these are the dimension table which we are relating with a single fact. Okay, this we can call it as a star schema. This we can call it as a star schema. The fact table joined with multiple dimension tables. Okay, here also you need to define that what is the relationship. So automatically the relationship built by the tableau itself when the matching field names are the common data where we have it, the field names are matched, automatically the relationship built by the tableau itself. When the column names are not matching, manually we need to give that. Okay, so that is a problem. Other than that, it will automatically take the relationships. Okay, based.
Srinivas, just I missed. So, I mean, in this department text logical, can you double click once on that department text logical table? What it is. I just missed it. I mean, what you created in physical layer. So, acha, you have added a department text to with employee text. Okay, okay. Join.
Yeah, just I
Okay,
joined
Srinivas.
here, physical join.
Yeah,
Okay,
okay. Okay.
okay, like this we can build that. So these two are different data models and physical data models. You can say that this is a one physical data model, and we have the one more physical data model here. Okay, so you can relate it those two. Okay,
Thank you, Srinivas.
yeah. So this is the way we can design a star schema. Even if you have the snowflake schema, that's also you can build it. You need to drag it here and drop it. Okay. Let's hang it. Let me clear this one. Okay. So before going to this, if I remove my root table, all the tables can be get removed from the canvas. Okay. So if you remove the root table, all can be removed from my root table. So let's go for discuss this. It's like what is the main differences between uh, logical and physical tables. Okay. So let me make it as presentation. So in previous version of Tableau, the data model only we have it physical layer. Okay, we have it only physical layer, and where we can design the physical joints. In 2020.2 version onwards, Tableau 2020.2 version, they introduced that logical layer. That's we can call it a semantic layer. That's we can call it as a semantic layer and logical layer. Okay, this give you more options, combine data using the schemas to fit your analysis. Okay, there is a more usage using the physical layer. So how the logical layer is? Logical layer here, see that logical table 1, logical table 2, those are relationship. Those are related to each other. Under that, what would be when we click on logical table A, so you can see that logical table A is data model is there in the physically. So where logical table A made is 4 tables, physical table A, B, C, D kind of thing. This physical table A is joined with 3 dimensions. Okay, which can be joined with 3 dimensions. Okay, this kind of physical layer joints you can make it. What are the types of joints you want it? You can go for use them, and you can create a data model in the physical layer level. Okay, in the physical layer here, physical table B, it has only one table. The logical table can have only one table, but when you go with the logical table A, it have the data model, star schema kind of data model is there. But finally, you can go for related this logical table A and B uh, under what are the physical joints are there. Okay, we can relate it these two, right? So this kind of model we have it, the relationships, and these are the physical layers. These two are individual. See that physical layer, this is the physical layer individual, and this physical layer is individual. On top of it, we are relating each other, logical A on logical table B. Okay, so again, you can see previous version of the data, previous table, data model would be physical table 1, 2, 3, 4, which is joined, and the same data source, data model, which we have it, joins. It is from the 2022 onwards. Okay, so what is the difference between physical layer and logical layer? Relationship canvas in the data source space. The relationships are there in the canvas at data source level, and join union canvas in the data source space. Okay, joins and unions we can do it as physical layer level. Okay, physical joins and union we can do that. And tables that you drag here are called as a logical table. So if you drag any table into the canvas, that's we can call it as a logical table. And if you go with a double click on it, table that you dragged here and called it a physical table, and double click on it, we can call it as physical table. Logical table can be related to other logical table. Physical table can be joined or union to other physical table. Okay, logical tables are only related each other, and physical table can be joined using the different types of joins, and union also we can do that. Logical tables are like a containers for the physical tables. Logical tables are like a containers for the physical tables. And double clicking on the logical table, you can see the physical tables. A level of detail is at the row level of the logical table. Level of detail in the row level of the merged physical table. So what happens is data can be merged into the all the physical tables. Okay, logical tables remains distinct, normalized, not merged in the data source. Okay, we are not merging that logical table, the main difference. And physical tables are merged into a single. So what are the physical join? You can do that. Based on that, all the physical tables data can be merged and will become a one. Flat the data defining the logical table. Okay, these are the main differences. Last one. Okay, just they are saying that where we have the logical and physical, the main difference is the merging the data. And
So
you
here
can see,
so majorly we will play with the physical tables, right? To have anything.
yeah,
So
physical tables where we have it, physical joints is required. The main when you go for physical table join is if we have the two different schemas, Ravi. So one is related to one fact table. When is we have another dimension the same different fact, then we can go for use the physical joins. If we have only one data model, then we can go with logical only. So what happens is if you give the physical join, all the tables can become a one data set, and getting the data from that, you need to check entire data set, right? How many
exactly.
records are there? All the records we need to be read it and I find out that records and put the output. Whereas if we go with a logical table, No need to go with that. Okay, Tableau will take care of that. It's an individual normalized data. If you say that where the fact table, then automatically related dimension table data, Tableau will take care. It will bring it. Okay, because both are the individual. Data was not merging with each other.
Okay.
So
Tableau will be taken care of for this
the data
last
pulling into that.
data pulling. Okay.
So Srinivas, it will take care only the time of runtime, right?
Yeah.
Okay.
So that's why they introduce the relationships on top of the physical joint. Earlier, they have only physical joints, and they bring into the relationship in the latest versions.
Okay.
Okay. So blending, once blending is completed, I will explain this. What's the difference between blending and relationships? Okay. And here you can see that relationships provide the several advantages over the using a joins for multi-table data. Okay, where we have the more number of tables. You can see that what is the advantages here. And see on top of it, relationships are the dynamic, flexible way of combining data from multiple tables for analysis. A relationship describes how two tables are related to each other based on the common field, but does not merge the table together. We are not merging the data table together. And when relationship is created between tables, the table remaining separate, maintaining their individual level of details and domains. So the tables, they can maintain the individual data itself. Okay. Whenever we require it, we can go for combine data and pull into the visualization. Whereas if we go with the physical joins, data can be matched. Some people affectionately call relationships as the noodles. Okay, we recommend using the relationships as your first approach to combine your data because it make data preparation and analysis easier and more initiative. Okay, that's why we are going to be use it. Relationship is a first step. Relationship provide the several advantages for using the joins for multiple tables data. You don't need to configure any joins like that between tables. You only need to select the field to define the relationship. Okay. And related to table remaining separate and distinct, they not merge into the single table. Relationships use joins, but they are automatic. Tableau automatically select the join type based on the field being used in the visualization. Okay, during the analysis. Tableau adjusts join types intelligently and preserve the native level of details in the your data. Tableau uses relationships to generate a correct aggregation and appreciate joins during the analysis based on the current context of the field used in a worksheet level. Okay, these are the advantages they are providing with the relationship. Okay, multiple tables at different levels of details are supported in a single data source. You can build a data model that containing more tables and reduce the number of data sources need to be built in a visualization. Okay, unmatched measure values not dropped, accidental loss of data, avoiding the data duplicate and filtering issues that can be sometimes result from the joins. Tableau will generate a queries only for data that is relevant to the current view. Okay, these are all the advantages which we have it. So here there is no practical thing. We need to understand that what is the relationship and what is the join. Okay, then automatically background process everything is happens and what exactly the relationships and theoretical part only we have it. Once we can go for it's like I will generate two data models. So star schema data sets. So I will show you that how we can physically create the data model and we can relate it with the other data model. I will show it in the further class. Okay. For timing, the data model is not ready with me. I'm checking for that. If it is get ready, we can create one more physical layer data model and one more physical layer data model here, and we can make it as relationship. Okay, we can make a relation to those two logical. Okay, that's we can say it. All right. So here, let me go with the Tableau desktop level. So these features, it's like requirement for relationship and a factor. I will share you this document anyhow. Okay, just go with that. Meanwhile, so can we use multiple sources and we can build the data visualization on top of it? multiple sources means one is the Excel, one is a text, and one is a Snowflake. Can we take the multiple sources? This is the only connection I have it, right? This is a Snowflake connection. Okay. Can we create multiple connections? Yes, we can create the multiple connections here. Okay. Clear this sheet. Okay. What is the error? Just try to rectify this. There was a problem connecting with the data source of this, editing this data source. Right mouse it, edit data source. We go back to the data source level. Okay. I'm removing this. Okay. Drag the EMP logical and DAPT logical as. So here it automatically build the relation. See, these two tables are there in Snowflake. Already we define the relationship between these two. That's why it will take automatically the relation between these two tables, EMP and DAPT. Okay. So what we said that if you want to extract the data, just click on extract. So what are the main filters which we data source level? What are the types of filters we can need at data source level? Can anyone? Yesterday class we discussed that, right?
Extract filter and global filter.
Extract filter and
Global filter, data source filter.
yeah, extract filter and data source level filter. While you are extracting the data, if you filter your data, that's we can call it as extract filter. And what are the filter we are going to apply at data source level? That's we can call it as a data source level filter. In the order of execution, which will be execute first?
Extract.
Extract first, and next it will go for
Globus.
Data source.
Yeah. So while extracting the data, you can filter your data. That's we can call it as extract filter. That we can go for define it, edit. Okay. If you go with the filter option is there, add filter. Okay. On top of which field you want to filter it, you can select that and filter the data. Salary, suppose I want to filter on salary, where my salary is greater than 5,000 and above. I want to get that data only into my extract. We do that. Okay. Extract contain where salary is greater than 5,000. So what is the difference between live connection and extract connection?
In live connection, Tableau will be directly interacting with the live database.
Yeah. Okay. The extract connection?
We are saving the data in our in memory, and then we'll start working on it.
On top of it, we build a visualization.
Right.
Exactly. Correct. Okay. So live connection means we are directly interacting with the database server. Okay. We always connect to the database server. For each and every visualization, we'll fetch the data from database. Okay. For each Tableau, what it will do is it will generate a query and it will send it to the database. It will generate a query and it will send to the database and fetch the data for each and every visualization. Okay, where go for extract connection, we are taking, we are dumping the data. We are taking entire data from database to our in memory, and we are saving in which format we are saving that? Extract format.
Hyper.
Sorry,
Hyper format, dot hyper.
we are saving the data in the dot hyper format. Okay, Tableau supported format it was. We are saving that in the dot hyper format. Okay, so we can get it. The difference of that extract and live. This is the difference. We are going to be take the data from this extract, we build the visualizations. Okay. So second connection. So this is the only one connection I have it, which I'm making to the my uh, uh, Snowflake. I want to create one more connection. As we can create it, add which data source you want to connect it for the second one. Which data source you want to connect it. I want to go for connect my Microsoft Excel. Click on it. Okay, where you have that Excel file. I have one more file, documents, my, excuse me, Tableau repository, data sources. Okay. I have sample superstores Excel file. Click open. Okay, you can have the one more connection and one more source file as well. Okay, you can double click on it here.
So Srinivas, there are two default sample data sources provided by Tableau, right?
Yeah.
One is sample
Yeah.
superstore and another is world indicator something.
Yeah, this is the data sources we have with the Tableau desktop. Okay, we can get it from the Tableau desktop. That is the file I am
With the installation, it comes now. Installation.
Yeah, with
Installation.
installation, we get it.
They have given free, actually.
Yeah. Okay, just you can remove it at this level. Okay, go for a sheet level, and from here as well, you can connect to the new data source. Click on it, go for take it to Microsoft Excel and sample superstores. Okay, so one more data model diagram, we can do that orders. So peoples and returns. Okay, these are the joins we had it. So orders, people, return. So now, so try to understand, if you want to go for work on any organization or any data domain, you need to understand that what kind of data client was using. Okay, what kind of data client was using. So mostly our entire sessions, we can be use this data set as a practice purpose. So try to understand what kind of data we have it. Order ID. Order ID means something the client customers are ordering. The order ID is this, and order date when they have ordered, and what is the ship date. So order date is this, and delivery date is this, ship date. And different types of ship modes are there: second class, first class, standard class, and different types of ship modes of that particular order. And customer ID, who is the customer and who given that particular order. Okay, and you can go with. So any case meeting close, join back with the same link. Okay, so customer name, segment, customer name and segment, and we have that country, from which country, what is the city and state, postal code of the customer, okay, and region, what kind of product they are ordering. Okay, they're ordering online shop house, what kind of product it is, and what category it belongs to, and what is the subcategory, what are the different product names. Okay, sale amount, quantity of sale, and discount if there any discount, discount amount, and profits. Okay, this is the entire field table I have it, entire table I have it. Okay, so let's go for take this data set for our practice purpose. Okay, so this is a data model, we did it. Just go for sheet 1. Let's go for sheet 1. So here you can understand that few fields are in the blue color, few fields are in the green. You can see when I'm moving my mouse over the fields, few fields background is blue color, right? And few fields are showing in a green. So color is representing that these are all the discrete fields, these are all the discrete elements. Okay, these are all the discrete elements, these are all the continuous elements. Green color represent that's a continuous element, blue color represent that's a discrete element. Okay, these are all the discrete, it means dimension elements. Discrete elements is nothing but a dimensional elements, and these are all the measures we can call it as a numerical values. Okay, blue represent that discrete values, and green represent that continuous values. Okay, numerical values. Continuous means, suppose sales will if we drag it into here, what happening, it will generate a access 0k to the value of that. Okay, range of values. Okay, the continuous field will give that range of values. Whereas if you drag the dimension field, the segment, if you drag it, it will give the individual value, distinct values. Okay, consumers, corporate, home offices. That's why we can call it as discrete. All the dimension elements we can call it a discrete fields, and all measure elements we can call it as a continuous element. So any case I want to,
Srinivas, so just measures can also be discrete, right?
that's what
Measures.
I'm going to tell it. Okay, so here anytime you can move that discrete element to the continuous element to the discrete. Okay, you can convert them. Okay, you can simply drag and drop it into here. That's you can make it as discrete element, and you can drag that order ID into the measure part. That's we can become a continuous element. So based on the requirements, we may change them. Sometimes the numbers which are distinct, 4 number is there. Okay, 4 number is distinct or continuous element?
Distinct.
Distinct.
Yeah.
But it will fall under the continuous because it's a number. Because it's a number, it will fall under the continuous elements because it's a number. But it's a distinct, because why it's a distinct is The phone number can assign to the only one person, one number. The number cannot be duplicate, or the number cannot be assigned to the another person. Right? That's a distinct. Student ID. Student is distinct or continuous?
Distinct.
Distinct. So when you go for count of students, then you need to make them as a continuous, because I need to count it. I need to do the aggregation on that. Then you need to drag into the continuous sometimes. Okay, that's why you can anytime you can convert the discrete element to continuous element to discrete. But I have the few fields are there. Suppose customer name is there. It's a distinct field. I want to count of the customer names. Yeah, you can drag it. Okay, you can drag it, count of the customer names, we can get it. Okay, but anytime whatever the fields you have it, you can go for drag them into the continuous, and the continuous elements wherever I have the measure sales, I have it. If you drag that into the distinct, let's see what happens. What it giving? Distinct values. Each and every transaction, whatever the each transaction happen, those many records you can get it. You don't get the summarized data here. Suppose I have it segment here. Are you getting segment? Drag it here. See that? I want to see that consumer wise total sales I wanted. Does it getting consumer wise total sales? No, the individual values we are getting. Okay, so individual, but it's my requirement corporate wise total sales I wanted. It's not getting the total of corporates wise. So when you make it as a discrete, sales as a discrete, it doesn't give you the total value related to that particular dimension. Okay, generally what is the report means? So the segment wise total sales I wanted. Sum of the sales based on the corporate, based on the consumer, what are the segments are there. But when you make it as discrete, it doesn't give that. Okay, that's why the sales measures always in measures part. Now we drag it into the rows or columns. It will give the total value of that particular segment wise. Consumer wise total sales, corporate wise total sales, home office wise total sales. Okay, we can get the total.
Cannot we aggregate district sales? I mean, discrete sales, aggregation.
You cannot aggregate it. If you make it as discrete, that's the main. Even if you have it in a discrete, you cannot aggregate it. Okay, individual. Discrete means it's a individual values. Okay, so measures can be get aggregated. You can apply the sum or rule, sum or average or mean max on the numerical values only. Right? Can we sum the names?
No.
That's a discrete values. Either you want to count the names of the customers, then you need to convert into the continuous. Then only we can get the count.
We can sum up the telephone numbers.
Yeah, we want telephone number. Telephone number is there. We don't sum it because there is no proper result. What is the use of that?
We can count as I mean,
Yes.
converting it into continuous.
Yes, we can count them. How many telephone numbers are there in that particular village or city kind of thing. Okay, so that's the main difference between dimension. It's like discrete fields and continuous fields. The continuous field always the background, you can see that the green color would be there, and dimension field is a discrete field. The background color will be blue. Okay, so these are all elements called as discrete elements, and these are all elements called as continuous elements. So here, what are these are all the options? What are these are all the options? Okay, so you can see that rows and columns are there for us to build a visualizations, the rows and columns. Whatever the field you want to drag it, you can drag into the rows. Whatever the field you want to drag into the columns, you can do that. Okay, when I drag my subcategory into rows and sales into the columns, I can get the subcategory wise sum of sales in a horizontal bar chart. Okay, so now I want to vertical bars. So I want to drag my sales into columns. I want to drag my subcategory into columns. Then do that, just swapping. The option is there, swapping rows and columns. Click on it. We can get the vertical bar chart. Okay, swap the fields here. Rows to columns, columns to rows. Okay, so this is not a clear. I want to make sorting of the data. Based on the sales, I want to sort the data. The sorting options are here. So ascending order, descending order. just click on that ascending order. What happened? I thought meeting is closed or what?
Meeting, we can hear you.
Your meeting, we are still something is happened. Let me open the Tableau desktop. So everyone install the Tableau desktop, right? So once 14 days is completed, just try to get that student ID and apply it in that as in the video shown. Okay, you can get the student ID card here. So I can give you that interview questions as well. So I'm preparing the list of interview questions. Okay, we can go for discuss them. And just you follow this interview questions, you simply crack the interview. Okay, if out of these questions, if they want ask you any question, just ask, just contact me. Only these questions is enough. I will give almost what are the interview questions people are asking. Just go with them, enough. Just you have, if you buy hard it or whatever you do, just if you give that answer, enough. Okay, even answers also I will provide you, nothing to worry. Okay, so one of the interview they will ask you there's many questions. Okay, just started listing out that questions. Okay, we have the Genpack interview questions and a few other what's the interview questions kind of thing. So I'm listing out. So answers also I will give you nothing. If there are any scenarios, the scenarios also will be included here. Okay, and they will ask you the database related questions as well. So when I open it back, it's asking me my Snowflake password. Okay, so let me connect to, so this is the one connection we have. I want to connect to my sample superstores. Click on new data source connection, go with the Microsoft Excel. Okay, sample superstores, click on it. Okay, I will click on orders, table, and returns. Even if you double click on it, automatically the join will click on orders. So go with the sheet 2. So here you can see that two connections are there. One is my Snowflake connection. This is one related to the sample superstores. Can we create one more connection? Yes, we can create one more connection as well. Okay, a number of connections we can go for, but individual report. Based on this, I can build multiple visualizations, and based on this connection, I build multiple visualizations. Okay, so and combining these two sources of visualizations can be built into the single dashboard. We can pull that the different sheets which is from different sources. Also, we can put into a single dashboard. Okay, it will be possible. Okay, so here what we are discussing is just select the subcategory and click on sales. Okay, you can drag it into the columns. We can get the horizontal bars and swap them. You can click on, we can get the vertical bars and sorting as possible based on the data. See that? So descending order and ascending order. Sorting option is there here. Okay, sorting option is there. Okay, based on multiple dimension field, I want to, this is a subcategory wise. Go for one more sheet where I have the subcategory wise sales. Okay, drag it here and swap it, descending order. Here I want to drag the category as well. Category as well. Drag the category into the columns. You can see that furniture, office supplies, technologies is the three different categories. The related subcategories is chairs, tables, bookcases, and furniture. Storages is a different subcategories related to office supplies, technology related subcategories. These are all. Okay, we can, this is a T symbol is there, label marks. So if we click on it, we can get the values next to the bars. Okay, so this we can bring it, sorting and swapping the rows and columns and columns and rows. So it's like however you want it, you can swap it. I want to category and subcategory in rows and columns. The visualization can be changed based on the sales. Always sales in the access, we can get it the value 0 to what is the total value we have. Okay, this is what about columns and rows. Next, come to here. So filters is there and marks is there. What is the filter? Filter is nothing but restricting the data into your visualization. If you want to restrict your data into the visualization, you can go for use that filters. Okay, so next session, next concept is filters. We can go for it. Meanwhile, we can complete this marks part. What is this marks? What are these uses of these marks? Okay, so what are there in the marks list? Colors, size, labels, details, and tooltip. This is the 5 marks which we have. Okay, so what is mean by color? If you want to apply the colors to your visualization, we can use that color mark option. Okay, color shelf, we can call it a color shelf. Okay, so I want to get a individual color for my category. Furniture, I want to get in furniture bars all in one color. Office supplies, I want to display in one color. Technology, I want to display in one color. Then drag that category into color shelf. Then drag that category into color shelf. We can get it category wise different colors. Furniture in one color, office supplies in one color, technology in one color. Clear? Here I will give you the one more difference between discrete to continuous. Okay, I will show you that. Okay, so here I drag my dimension field, discrete field into colors. We can get the 3 different colors here, right? One is in blue color and yellow color and red color. So same sheet, you can duplicate it. If you want to build the same similar sheet in the, one more sheet, just click on duplicate it. We can go for it. Okay, no need to drag these are all into rows and columns. You can simply duplicate it. Okay, let me remove the category here. Remove the category also here. So here you can see that different subcategories are there. If we drag the subcategory into colors, what happens? We can get the distinct colors to the each and every subcategory. So here each and every subcategory has a individual colors. Okay, we can get it subcategories, different colors. Subcategories, different colors for each and every subcategory. So when you drag the your discrete field into color shelf, you can get the individual colors. Discrete field into color shelf, you can get the individual colors. Continuous field. Let me drag my sales into the color shelf. Let me drag my sales into the color shelf. What happened? I can get the gradient color. Okay, so here you can change your color formats, whatever you wanted, red to green. Okay, gradient color you can get it. That's a measure you drag into color shelf. The continuous fields always give the gradient colors. Discrete fields give the individual colors to your visualization. Okay, so how we can use this color shelf? You got it? What is the use of color shelf? So conditional, based on condition, where my sales is greater than 1 lakh, I want to green color. Where my sales is less than 1 lakh, I want in red color. Yes, we can do that. We can write a calculation on based on sales and we drag that condition into colors, we can get it. Okay, sales greater than 1 lakh, the sales is greater than 1 lakh, I want to get it in green color. Sales is less than 1 lakh, I want to get in red color. That's also we do that. Once we write the calculation, we drag into color shelf, we can get that condition based. So in the next classes, we can see that. Okay, so this is the use of the color shelf. This is the use of the color shelf. Okay, and what is the label? This text. So showing this label marks, the text will be work, show mark labels. If you uncheck it, it doesn't show anything. If you check it, then only the values can get displayed here. At the same time, okay, let me labels. The main part is the labels only here. If we go